Oh, these notes are for 2.3, Algebra 2. I'm just grabbing my notes here. 2.3 parts A and B. Factoring review and factored form of a quadratic function. And these would have been for if your second period, Monday 10:19, and if your fifth period, it's for Tuesday 10:20. And so the 2.3 homework is online and it's due by next class. So let's hop over to 2.3. This is probably the slow way of getting there. First, we review factoring. There are, you've probably done this before, unfoiling. A quadratic trinomial is this guy. There's two types, where a is equal to 1 and where a is greater than 1. So an example of this would be 2x squared plus 7x plus 3. That's a quadratic trinomial where a is bigger than 1. X squared plus 9x plus 14 is an example of a quadratic trinomial where a is equal to 1, because we just never write the 1 that's in front of an x or an x squared. And then we have difference of squares. This would be like x squared minus 9. We actually have a formula for this one, a squared minus b squared. And when you factor this guy, we get a plus b times a minus b. So I'll explain that more when we get there. First, we're going to do factoring where these guys are a is bigger than 1. This is sometimes called the AC method because that's our first step. We multiply, in this problem, a is 2, b is 7, and c is 3. ax squared plus bx plus c. ax squared plus bx plus c. So we multiply a times c. For this problem, 2 times 3. And 2 times 3 is 6. And what we do is list factors of 6. So things that multiply to 6. 1 times 6 or 2 times 3. And then what we do is we choose the pair that adds to, I meant to write sum, that adds to the middle term, the b value. Sum to b. Our b value here is 7, so I'm going to choose 1 and 6. What I do with the 1 and 6 is I'm rewriting my original problem. Instead of writing 7x, we're going to write 1x plus 6x. 2x squared plus 1x, or just x, plus 6x plus 3. And then from here, we factor by grouping, FBG, factor by grouping. Factor by grouping is where I take the first two and I just factor out whatever I can. It's called the GCF, greatest common factor. See how they both have an x? So I can factor out the x. I'm undistributing. It's like the distributive property in reverse. So now I'm thinking to myself, x times what is 2x squared? 2x. Because after I distribute this, I should get this guy. So we're undistributing. And x times 1 is x. Then I do it to these two. 6x plus 3, I can take out a positive 3. 3 times 2x is 6x squared. 3 times 1 is 3. So what happens is that binomial is the same. And if it's not, you got to start over because it should be. And then we're factoring that binomial out. So my final answer here is 2x plus 1 times x plus 3. So the monomials that are in front, those come together to make your second binomial. And the binomial that's the same in each of those is your first binomial. And this is our answer. Now, remember, when we're factoring, we're unfoiling. So FOIL, F-O-I-L, is multiplying two binomials. You may have heard of FOIL before. So if I multiply this back out, I should get the problem that we started with. 2x times x is 2x squared. FOIL. FOIL to check. Outside, 2x times 3 is plus 6x. Inside, 1 times x is x. Last, 1 times 3 is 3. And our like terms there combine, 2x squared plus 7x plus 3. And that was our original problem, so I know that I've done it correctly. But this guy right here, 2x plus 1 times quantity x plus 3 is our answer. These go a little faster when I don't have to explain everything, every step like that, and write it all down. So I'll do a couple more, and then I'll want you to practice a couple. 2 times 4 is 8. Factors of 8, but I'm also paying attention to that middle term. The factors that I choose have to multiply to 8, but they have to add to negative 9. So I wouldn't use negative 2 times negative 4. I would use negative 1 times negative 8. Negative 1 times negative 8 is positive 8. Negative 1 plus negative 8 is negative 9. And now I rewrite our problem. 2x squared minus 1x, or just minus x, minus 8x plus 4. And now I factor by grouping. Here I can take out an x, 2x minus 1. And I have a little hint for you. On this, when you do the second pair, you can just copy down whatever's inside of those parentheses, 2x minus 1. And then now I just have to think about what would have to sit in front there so that it would distribute to give us negative 8x plus 4. So that would be a negative 4. Negative 4 times 2x is negative 8x. Negative 4 times negative 1 is plus 4. So now our answer is 2x minus 1 times x minus 4. So I want you to pause and do examples 3 and 4. And then unpause to check your work so that you can practice this. All right, 3 times 6 is 18. Factors of 18, 3 and 6, 1 and 18, 2 and 9. 2 and 9 add to 11. So 3x squared plus 2x plus 9x plus 6. And by the way, it doesn't matter which of those you put first. I'll show you that at the end. Factor by grouping. I can take out an x, 3x plus 2. Copy down 3x plus 2, and sitting in front would have to be a positive 3. 3 times 3x is 9x. 3 times 2 is 6. Final answer, 3x plus 2 times x plus 3. Now, what I was saying before is, what if, when you rewrote yours, instead of 2x plus 9x, you put the 9x first. So watch what happens. 3x squared plus 9x plus 2x plus 6. Now when I factor by grouping, here I can take out a 3x, x plus 3, copy down x plus 3, and sitting in front then would have to be a plus 2. So my final answer is x plus 3 times 3x plus 2. And look at that. These two are the same thing. The factors are just written in a different order, and that's totally okay because it's just multiplying. When you're multiplying, it doesn't matter the order. 5 times 7 is the same thing as 7 times 5. So it doesn't matter that order. One more for practice. 2 times 12 is 24. Factors of 24, 4 times 6, 2 times 12, 8 times 3. 8 and 3 add to 11. Rewriting 2x squared plus 8x plus 3x plus 12. And factor by grouping. First pair, I can take out a 2x, x plus 4. 2x times x is 2x squared. 2x times 4 is 8x. And copy down x plus 4. And sitting in front would have to be a plus 3. My little pens aren't working very great today. Final answer, x plus 4 times 2x plus 3. Quadratic trinomials where a is greater than 1. When a is equal to 1, so these problems on down, these are actually a lot easier. Because when I multiply a times c, a is just 1. So the number, I'm still doing the same process of I've got to think of numbers that multiply to 10 that add to negative 7. So that would be negative 5 times negative 2 is positive 10. Negative 5 plus negative 2 is negative 7. But now, instead of having to do that whole big process like we did up here, these two numbers that I choose, those are the numbers that go into the binomials in the answer. Our answer here is x minus 5 times x minus 2. Always please remember you can FOIL it out, multiply it back out to check your work. X times x is x squared. Outside is minus 2x. Inside is minus 5x. Last is plus 10. And there's your middle term, negative 7x. So we did it right. Please do, let's put some negative ones in here. Please do number 11, number 10, and number 9. 9, 10, and 11 for practice. Pause the video and then come back. So I need two numbers that multiply to negative 24 that add to negative 2. So that would be 6 and 4, and it would have to be a negative 6 and a positive 4. X minus 6 times x plus 4. Do a little FOIL, even just in your head to check it. X times x is x squared. Outside is plus 4x. Inside is minus 6x, which gives us the negative 2x. 6 times 4 is 24. Negative 6 times 4 is negative 24. Here, two numbers that multiply to 2 that add to 3. 2 and 3. X plus 2, x plus 1. 2 times 1 is 2. 2 plus 1 is 3. And finally, multiply two numbers that multiply to positive 15 and add to negative 3. So that would be negative 5 and negative 3. X minus 5 times x minus 3. And always please remember that you can flip those around and it's the same thing. X minus 3 times x minus 5 is the same thing. And then our difference of squares. So our formula was a squared minus b squared. That's the problem. The answer in factored form, a plus b times a minus b. So I want to explain why that is. Why is there only two terms? These are called difference of squares. You've got a perfect square, and there's a minus sign between them. Well, let's FOIL this out to check our work. A times a is a squared. A times negative b is negative ab. Inside, b times a is plus ab. And L for last, b times negative b is minus b squared. Negative ab plus ab adds to 0. So those terms cancel away. We're left with a squared minus b squared, which is the problem that we started with. So that's where this formula comes from. Unfoiling. So what I need to do these is identify the thing that's being squared. What do you square to get x squared? X. What do you square to get 9? 3, because 3 squared is 9. So the x and the 3 are like the a and the b in the formula, x plus 3, x minus 3. What do you square to get x squared? X. What do you square to get 49? 7. So our answer is x plus 7 times x minus 7. What do you square to get 4x squared? Sometimes there's a number in front, so 2x. And we square 5 to get 25. So 2x plus 5 times 2x minus 5. Please do the next row as practice, 16, 17, and 18. Pause the video, do those, and then come back. Here we would have 2x plus 3 times 2x minus 3. Here, 5x plus 7 times 5x minus 7. Again, the minus 1 can go in front. Doesn't matter. And don't forget, 1 is also a perfect square. 1 squared is 1. So I'll put the minus 1 in front this time. X minus 1 times x plus 1. The order doesn't matter. This was mixed practice. If you'd like to do those, feel free for extra practice. Otherwise, we are going to move on to the real part. So that was all just review, so that we could talk about the factored form of a quadratic function. Example 1 here, those are what we just did. The graph shows the function defined by y equals x squared plus 2x minus 8. How do the zeros of the function relate to the factors of the expression? Well, let's factor this guy. Two numbers that multiply to negative 8 that add to positive 2, so that would be 4 and negative 2. X plus 4, x minus 2. Well, look at, they gave us the graph of this parabola. Look at where the x-intercepts are. They're at negative 4 and positive 2. So negative 4 and positive 2 are the intercepts. So notice they're the same, the x-intercepts to be precise. And by the way, they're called x-intercepts. Sometimes they're called roots, and sometimes they're called zeros. The zeros are the opposite sign from the factors, and that's what we're supposed to be pointing out here. And by the way, this is a quiz question. When the next quiz you take that has 2.3 on it on Teams, it will ask you to say what is the relationship between the function, or rather the factored form of the function, and the intercepts, roots, zeros. All right, so this one, let's put it into factored form. Two numbers that multiply to positive 20 that add to negative 9 would be negative 5 and negative 4. So x minus 5 times x minus 4. That means the roots, or the zeros, are going to be positive 5 and positive 4, which we can see on the graph here. Positive 5 and positive 4. So this leads us to the factored form of a quadratic function. Y is equal to, we're going to have our a value in front, plus it could be positive or negative, and then our two parentheses, x minus p times x minus q, where p and q are the zeros, the intercepts. Notice how they're the opposite sign. The formula says x minus p. P is the 0, x-intercept, x minus q, q is the 0. We also use something called the zero product property. It says this: if a times b equals 0, so you have two things multiplied together and they equal 0, then you can separate each of them out. Then a equals 0 and b equals 0. So, but first I need to say, when we solve a quadratic equation, we have to put them into standard form first. Ax squared plus bx plus c. I'm noticing this one is not, and equal to 0. Everything on the left-hand side equal to 0. So this one, I'm going to subtract the 42 over. So now x squared plus x minus 42 equals 0. And now it's in standard form now, and now I can put it into factored form. So I need two numbers that multiply to negative 42, that add to positive 1, 6 and 7, that would be a plus 7 and a minus 6. X plus 7, x minus 6. So now here, where I'm going to use the zero product property, I've got two things being multiplied together that equal 0, so I'm going to separate them out. X plus 7 equals 0, x minus 6 equals 0. And then I would solve each equation. So here I would subtract 7, getting x equals negative 7. Over here I would add 6, getting x equals 6. So that's the reason why when you, in factored form, it was plus 7 and a minus 6, but then the solution, the roots, the zeros are the opposite sign, is because you're solving that equation for 0. Here is another one. Everything onto one side, so I have to add the 9x over, and we also have to subtract the 5. So now on the left-hand side, we have 2x squared plus 9x minus 5 equals 0. And now we're going to factor it. This is the bigger kind because a is greater than 1. 2 times negative 5 is negative 10. Factors of negative 10. Negative 1 times 10, or 1 times negative 10. Negative 2 times 5, or 2 times negative 5. We need the pair that adds to positive 9. So negative 1 and positive 10. I can rewrite my problem now. 2x squared minus x plus 10x minus 5 equals 0. And now factor by grouping. I'm going to take my first pair. I can take out an x. 2x minus 1. Second pair, I'm going to first copy down 2x minus 1 equals 0. And sitting in front here would have to be a positive 5. 5 times 2x is 10x. 5 times negative 1 is negative 5. So we've got our two factors. 2x minus 1 times x plus 5 equals 0. And set each factor equal to 0. 2x minus 1 equals 0. X plus 5 equals 0. And solve each equation. This one, x equals negative 5. And for this one, add the 1 over, gives us 2x equals 1. And then divide both sides by 2, gives us x equals 1/2. Two answers. You can write them separate like that. It would also be okay to answer it with a comma in between the two. I don't know how the online homework is going to have you do it, but you might try both ways. All right. Please practice these two. Press pause and then come back to it. I have to minus the 20 over. X squared plus 8x minus 20 equals 0. And now I need two numbers that multiply to negative 20 that add to positive 8. So that'd be 10 and 2. And it's a positive 8, so positive 10 and a minus 2 to give us the plus 8x. And set each factor equal to 0. and solve each equation, -10 and +2. And for this guy, everything on one side, 2x squared minus 3x minus 2. And AC, 2 times -2 is -4, so I need factors, two numbers that multiply to -4 that add to -3. And notice I'm looking, A, B, and C are determined from when it's in standard form. I'm not looking at the original anymore. 2 times -2 is -4, and things that multiply to -4 that add to -3 would be -4 and a +1. So rewriting 2x squared minus 4x, minus 4x plus 1x minus 2 equals 0. Factor by grouping, there we can take out a 2x, x minus 2. Copy down x minus 2, and when it matches, it's the same thing. That just means there's a 1 in front. So our two factors are x minus 2 times 2x plus 1. Set each factor equal to 0 and solve. We get x equals 2 and x equals -1/2. So I just visualize solving this. Minus the 1 over and then divide the 2. -1/2. All right. Marco hits a golf ball into the air from the 3rd level of a driving range that is 48 feet high. The function, blah, 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 gives the height, h, in feet of the golf ball t seconds after it is hit into the air. When will the ball hit the ground? So they're asking us to solve for t. When will the ball hit the ground? This function, h of t, height in terms of time, that's what h of t means. They're asking us, when will the ball hit the ground? When the ball hits the ground, the height of the ball will be 0. So we're replacing the h of t with a 0. -16t squared plus 32t plus 48. And now we can solve this. I like my equals 0 to be on the other side when we're solving. I just am weird that way. One thing we can do, instead of trying to factor this as it is, notice how all the numbers are divisible by 16. So, and also my front one is negative. So what if we divided both sides by -16? Both sides of the equation. On the left-hand side, there's 3 terms, so we'd have to distribute that through, divide all terms by -16. So then once we do that, then we get t squared minus 2t minus 3 equals 0. This is much easier to solve, much easier to factor. Now my a value is equal to 1, so this is much easier. Two numbers that multiply to -3 that add to -2. -3 and +1. So t is equal to 3 and t is equal to -1. Remember that we were solving for time, how long until the ball hits the ground. There's no such thing as negative time. So we just disregard that answer since we're talking about actual time. So our final answer then would be 3 seconds until the ball hits the ground. So I want to explain what that means graphically. Remember, this person was off the ground when they pitched the ball. So it went up and then it hit the ground. Well, that other x, this x-intercept is 3. The other x-intercept was -1, and that's like representing negative time. So that's why it doesn't make sense to have a negative number in this instance. So we would disregard this and just keep that one 0. There's one on the next page for you to practice. Please pause. And it looks like it's the same. It's the same question. How long will it take the ball to reach the ground? Here we have negative 16t squared plus 32t plus 128 equals 0. Divide everything by negative 16. We're lucky they give us ones that are divisible. Later on in the chapter we're going to learn different ways to solve these when you can't. Like if all of those terms didn't divide by 16, what would we do then? We'll learn that later in the chapter. So we get t squared minus 2t minus 8. This factors into t minus 4 times t plus 2. And solving, t equals 4 and t equals negative 2. Negative time doesn't make sense. 4 seconds is our answer for this one. Example 5. Identify the intervals on which the function is positive. This goes back to what we did in chapter 1. Positive means above the x-axis. So we want to identify the intervals. That means the x values where this parabola is above the x-axis. So what I want to do is take my function, it's in standard form right now, and we're going to factor it so it's in factored form. Two numbers that multiply to negative 3, the add to negative 2 would be a negative 3 and a positive 1. So that means the zeros, the solutions, are positive 3 and negative 1. That means the parabola is crossing through positive 3 and through negative 1. So the parabola is doing something like this. Where is the parabola positive? Above the x-axis. So I need to say those two different intervals. The leg on the left is from negative infinity to negative 1 in union with, so that U symbol. The right leg is from 3 to infinity. Two pieces of the parabola are above the x-axis. So please do this one for practice. Let's see, this would be 7 times 3 gives us 21. And so it would be a negative 7 and a positive 3. So our zeros, forgot my equal sign. Our zeros then, our x-intercepts would be 7 and negative 3. Negative 3 is over here, positive 7. Our parabola is doing this. Above the x-axis is in those two regions. So negative infinity to negative 3 in union with 7 to infinity. And the last question is, write an equation of a parabola with x-intercepts at negative 2 and negative 1, which passes through the point negative 3, 20. So it's telling us two intercepts and then some other random point on the parabola. We did this when we were in vertex form. The thing, to write this equation, we need the a value, x minus p times x minus q, the p and the q. Well, they're giving us the p and the q outright, so I could fill those out. But we don't know the a value. So we're going to use this other point as the x value and the y value to plug all of those in and solve it for a. Then we'll know what the a value is. So plugging all of these in, the y value is 20 equals a. That's what we're trying to find. The x value is negative 3 minus p, negative 2, times x is negative 3 again, minus q is negative 1. And minus negative means plus. We know this. Negative 3 minus negative 2 is negative 3 plus 2. Over here we would have negative 3 plus 1. Negative 3 plus 1 is negative 2. Over here it's negative 1. Negative 1 times negative 2 is 2. So we have, remember, all these are getting multiplied together. So negative 1 times negative 2 is 2, times the a is 2a equals 20. Divide both sides by 2 gives us a is equal to 10. So now I can write the equation for this guy because I know the a value is 10. Final answer, y equals 10 times my intercepts. Minus negative 2 would be plus 2, and x minus negative 1 would be x plus 1. Please do the last one, pause the video, and then check your work. So in this one, our x is 1, y is 2, p is 3, q is negative 3. Plugging all of those in, 2 equals a times x, which is 1, minus p, which is 3, times x is 1, minus q, which is negative 3. And that would be 1 plus 3. I wrote plus 3. 1 plus 3 is 4. 1 minus 3 is negative 2. Negative 2 times 4 is negative 8 times a equals 2. Divide both sides by negative 8. Gives us a is equal to negative 2/8, which reduces to negative 1/4. So our a value is negative 1/4. A is equal to negative 1/4 times x minus 3 times x plus 3. And there we go. That's it.